Up to this point, we developed our tests a bit haphazardly. Good software engineers do that with much more discipline. We want to be careful that we test every possibility. So when we're working with conditionals, we use the concept of border cases to make sure that we test all of the important situations. When we're testing conditionals, we usually cannot test all of the possible values, so we have to be smart about what we choose to test. In order to maximize the probability of catching an error, we want to test the situations that are most likely to be broken. For conditionals, we use the concept of border cases to find those situations. A border case is a situation where a small change in values causes a fundamentally different behavior. We're going to test both sides of that border because that's where the bugs usually are.
Here's an example. Suppose the system is supposed to say outstanding if you got a grade greater than 99 on an exam. The border is between 99, where you shouldn't see the output, and 100, where you should see the output. The if condition could be, if score is greater than or equal to 100, but suppose you forgot the equal sign. Then you've coded it as if the border case is between 100 and 101. If we test the required border, 99 and 100, you'll catch this bug because the behavior for 100 will not be correct.
Nice example. This kind of error is called an off by 1 error because the border case has been moved by 1. It is off by 1 value. These are really common errors. So, we're going to focus our tests on border cases. For conditionals, the border will always be 2 values, and we're going to test the values on both sides of that border. You can spot this in JUnit tests. There will be 2 asserts where the actual values use parameters that are very close to each other, and the expected values are different. When you see a JUnit test that looks like this, it's a clue that you need a condition that distinguishes those 2 values. This is a test for a method with a simple conditional. It has one border case between the values of 79 and 80, and the string that is returned changes at that value. Even though we're only testing 2 values, the implication is that every value that is less than or equal to 79 gets one string, and everything that is greater than or equal to 80 gets a different string. Here is one way we could write the method to satisfy this test.
Remember that the return statement does 2 things. Specifies the value the call on the method should evaluate to, and stops the execution of the method. So, in this case, if the condition is true, the first return statement will stop the method, and we'll never get to the second return statement.
Hey Zumi, is that the only way we could have written that?
Absolutely not. I can think of at least 3 other ways we could have gotten that behavior. Maybe our listeners should stop and see if they can come up with some other ways to get that same behavior.
Here's a test for a slightly more complicated conditional situation. In this one, you can see 2 border cases, between 89 and 90, and between 79 and 80. This divides the integers into 3 regions. The region from 90 up should return well done. The region from 80 to 89 should return good enough, and the region below 80 should return not good enough.
Drawing the requirements on a number line is a good way to visualize what the tests are asking for.
Here is a method that makes that test pass. Notice that it has taken a different strategy than the last one. The last one returned the value as soon as it knew what to return. This one holds the value to be returned in a variable and returns it at the end of the method. So that result starts with the value well done. At that point, it seems like the result is well done no matter what value x has. Then it overwrites it if x is less than 90. That makes the first border case work, but everything less than 90 will be good enough. The second conditional then overwrites the result again if the value of x is less than 80. Now we have our 3 regions and can return the result. Let's do one more level of complexity. This test requires 4 regions because there are 4 border cases. This solution uses a strategy similar to the previous one in that it holds the result until the end. However, because there are more situations, I was uncomfortable with overwriting the result variable more than once. Instead, I decided to be more specific about my conditions. Each of these conditions is checking to see if x is between two values. Think about this one. It's saying that we want all the values that are greater than or equal to 80 and less than 90. The only values that can make that true are 80, 81, 82, and so on up to 89. That is one of our regions.
Notice that Java didn't let us write between the way you do it in algebra. We had to specify the condition at each end and then combine them with ampersand ampersand.
You should stop and stare at this for a while to be sure you understand how it works.
Be the machine.
As things become more complicated, you'll find that there are many ways to code a particular behavior. Here are two alternatives for the test we just studied. Notice that these two are actually the same solution. I just got rid of the parentheses in the else statements to make them be else ifs. So a border case is a situation where a little change in a value makes a big difference in the behavior of the code. For conditionals, that's a pair of values that take different paths through the code. We can spot them in the tests as pairs of asserts which do almost the same thing but have different expected values. And as our code becomes more complex, there are a lot of alternatives for how you could write the conditionals. When we're comparing all of those alternatives, the thing that we're going to think about is how easy is it to read the resulting code? How much does the code really express what it's doing? And that readability is going to depend on things like how deeply nested the conditional statements are and how complex the conditions in those if statements are.